So yeah, it's just a lot of the time when you start at IS, you get all these different business units and you never understand the foundations. So it doesn't fit together properly. And I was saying earlier, that's probably why I didn't do too well at varsity, because I stuffed around in first year, and then the rest as well. So that didn't help. But not having the foundations right is never great. So this is to get the foundation. Some of you might have been trained by some of the business units already, so somewhat too late, but maybe the stuff will start making sense going forward. Also, it's not a hardcore technical training. So some of the stuff I actually don't know, and I just make it up as I go along. And it's just my understanding of how some things work. A lot of it also you don't need to know when you're speaking to clients, but it's nice to know some of the background stuff about how it all kind of fits together, and it just helps you think going forward. So it's kind of a training for going forward. And yeah, it's interactive, so ask me any questions, go wild, just have a chat. So yeah, the first thing I want to ask anyone, except for those who know already. It's better when someone doesn't know. A one-line definition of the internet. Anyone want to give me a one-line definition of the internet? No. Okay, you can be filmed, so let's get you on. One-line definition of the internet. What's the internet to you? If someone said, "What is the internet?" Just give like a one-liner. What is it?
A network of people connected via electronic wires.
That's a great definition. Anyone else want to give a definition? Anyone? Anyone feeling brave enough to give a definition? Okay, I've heard a lot of definitions in the past. I've heard it's the place where all the information in the world is kept. I've heard it's the place where you email. I've heard it's like the biggest library in the world. I've heard it's where you look, where all the websites are kept. I've heard a whole bunch of really weird things. But basically, my one-line definition of the internet is the interconnectivity of people around the world. So your definition is great. It's all these people connecting via technology. So it really means that the computer in your office is connected to your friend in the UK, is connected to someone in the US, it's connected to a website in Singapore. All of these things are connected. So the network is the way that all of these things connect. Things like email are what you do now that you're connected. Things like websites are what you can do now that this road is connected. So the analogy that I always like to use is a road system. It's an actual road system getting from point A to point B, and you can go there a whole bunch of different routes. If you want to drive and visit friends, you use your car on the road. If you want to shop, you use your car on the road. If you want to, whatever you want to do, you use the road system to get there. Okay, so that's so the internet is actually the road. And if you've seen those signs, I think we've got a couple of pictures up. It says the information superhighway. And I think the information superhighway is probably one of the best definitions of the internet for me, because it's the best analogy of what the internet is. Okay, so now the internet's all about these roads. Okay, and on top of that, you can do a whole bunch of things on top of the roads. So you can build shops, etc., etc. So anyone know how the internet started? Anyone know? Easy stuff. Bretsky, you know.
ArcNet.
Okay, so initially it was really a bunch of guys sitting in an office saying, well, we need to swap information from one computer to the other, and they used to have those floppy drives which are about this big, and to pull that out and put it into another machine, it's a waste of time. So you need to connect the two up and let them start talking to each other. So two computers started talking, a whole bunch of computers around started to talk. So if you've got one computer, another one, put it together. The third one connects and start putting it together. Fourth one connects, you start putting them together. Fifth one connects, you start kind of wiring them all together. That's obviously a fairly inefficient way of building a network, because this guy needs 3 different connections to connect to 3 different people. So a better way of doing that is to set up a central point, and you connect those central points up to a central point. Okay. So initially we started connecting computers, and when a computer is in a small area and all connected, we call it a LAN. Local area network, pretty easy. Okay, you all know what LANs are. And then as you start building a point and someone else builds a point like that, so we can start connecting those points up to each other. Instead of doing the same inefficient route as that, we shouldn't connect the big points together. We should have a central point where all of these points start connecting to. Okay? So you always try to get a central point. And for me, that looks like a web. So it's the World Wide Web. You know, the whole World Wide Web, it starts looking like a spider web. And as you start taking a local area network and you start taking it more than 50 kilometers, whatever the definition is, away, and you connect 2 of them up, it becomes a wide area network. So a WAN. So you might have heard of WANs, wide area network. Pretty easy stuff. Okay, so that's a LAN and a WAN, and how things started getting connected up to each other, and how the internet generally starts to build up. So all you need, if you're sitting at home and you want to go to Eastgate or Northgate to shop, I'm taking all the gates because of my surname probably. Yeah. Let's think of a different one. If you want to go to Santon to shop, you don't have to build a road to Santon. All you need is a driveway to get out of your house onto the road. From that road, you take another road, and the roads get bigger, and then maybe get smaller again until you get there. But you just need to get connected to that road system. So if you can connect into a point like that or a point like that, you are connected to this internet. Okay, and you can get anywhere and do anything you want to. So when IS first started, all we needed to do was connect up to that big network. So let me rub all of that out. Let me see what I was going to talk about next. Okay, so let's talk about the IS network. So network can be drawn as a line or as a cloud, either way around. Okay, and IS built themselves a network. And what we did was we connected up to the international internet. So we connected up to one of those little central points. International internet. And then what we did was we started connecting clients onto our network. Okay. So all we needed to do was connect to a really, really cool point internationally, and then people could get wherever they wanted. We just had to build one decent road, one big highway that people could get connected to, and then they can get anywhere else in the world. So we were reliant. Initially, we used to connect to the US, and we were reliant on the US connecting us to the rest of the world. Okay. In South Africa, other ISPs developed. So we got another ISP, and they would connect up to this international internet. Okay. And they might have had a client or two, not as many as us. And if our client wanted to talk to their client, theoretically they could go all the way overseas and back down to that user. So they were connected. So in South Africa, that's like saying, okay, I live in Joburg, this guy lives in Pretoria, let's drive to meet each other. And you have to drive all the way overseas through this massive highway and back from overseas on this highway. It's doable, it's possible, because in the internet world we do have highways. In the real world, we don't have this massive highway to the States, but in the internet world, we do. So you can drive that way, but it's pretty inefficient. So again, with that network design, we put a central point in South Africa called a peering point. And we said ISPs can connect up to that peering point. So IS connected to it, and a couple of other service providers connected to that peering point. Okay. The peering point in South Africa, we've got two of them that I know of. One is called Jinx, Johannesburg Internet Exchange, and it's in our Rosebank offices. The other one's called Syncs, Cape Town Internet Exchange, and I think it's also in our offices in Cape Town. But it's just a virtual point. So now all ISPs can connect up to there, and you don't have to drive all the way overseas and back. Okay, it reminds me of that joke. All of our international links remind me of that the guy who rubs a genie vase, and genie pops out and he says, okay, I grant you one wish. He says, I like Mauritius, and I like to go on holiday there, so build a highway from here to Mauritius. And the genie goes, geez, you know how difficult that is. That's concrete cement in the sea, under the ocean. It can get washed away, and have to stabilize it, and it's thousands of k's of tar, and so that's too much of a mission. Wish something else. He goes, okay, I want to understand how a woman's mind works. The genie looks, okay, so this highway, 2 lanes in both directions, a garage. So that's essentially what we've done. We built these big highways overseas. Okay, we built massive, and a satellite is a massive highway that goes overseas. Satellite connects up in the sky and comes back down, and then you get fiber links. And our fiber link's called SAT for some silly reason, bad acronym, and we connect via fiber. So that's like a tunnel going underseas to another country. So we've got satellite and fiber connections that go overseas, and those are our bandwidth costs. Our local lines and road system that we built, as well as our international road system that we built, these big bridges in the sky, as well as the tunnels under the sea. Those are our biggest expense at IS. They're more than all of our salaries put together, except for Brett's. So it's all of our salaries put together are not our biggest cost at IS. It's our bandwidth. It's our biggest cost. This is a huge, and that's what we invest in. Is those massive highways and roads. So so that's how we get connected to the international internet. At the moment, we've got connections to the UK and to the US. We've got satellite and fiber connections going all over the place. And the Access business unit will be able to tell you and keep you updated as to the latest connectivity and how much connections how big our connection sizes are, etc. Okay. That's basically how we all get connected. Obviously, IS drawn as a cloud there. We also have different branches around the country. So that might be Cape Town as a branch, and then Cape Town would then offer connectivity to a client. So a client buys predominantly the first thing that we ever sold was connectivity. They're connecting to us, and we connect them into this highway. Actually, IS was started by buying bandwidth from UUNet. We used to buy bandwidth from them. I think it was UUNet at the time, was iAfrica at the time, whatever it was. We used to buy bandwidth from them. We were a second-tier service provider until we grew big enough, and we broke away from them, bought our own international bandwidth, built our own international highways. Okay. So let's talk about what we actually sell them. We sell leased lines a lot of the time. And give me an example of a leased line. What size or whatever? 64K, right. 64K. What's the rest of the abbreviation? So what did you say? Kilobytes per second. Okay, that's wrong. Okay, it's kilobits per second. So let's have a look at what that means. A lot of the time we're selling 64 kilobits per second, but what does it actually mean? Let's break it down. 64 means 64, not rocket science. Easiest part of the question. Kilo, what does kilo mean? 1,000. Okay, so it's times 1,000. Bits, what is a bit? 8 bytes is a bit. Anyone else want to tell me what a bit is? Anyone? Everyone agree that that's right? No? Yes? Yes? No? Okay. A bit, let's talk about a bit. A B is a bit. Okay. And it is either a 0 or a 1. Okay. A capital B is a byte, and it's a collective term for 8 bits. So when you've got 8 bits together, it's called a byte. Okay, so it's the other way around. So a 0 or 1. So what's relevant about a 0 or 1? Does anyone know what the numbering system is called when you use zeros and ones? Binary. What's the number system that we use in everyday life? Yeah, numeric. What's the numeric system that we use? Anyone? Decimal, that's right. Okay, so we use decimal. And in decimal, how many numbers do we have in decimal? 10. What are they? Zero is a number. So we've got, in decimal, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we run out of numbers. We've got no more numbers left. So we decide to start again. So we put a 1, 0, 1, 1, 1, 2. Should be familiar. Okay. Binary, we've only got a 0 and a 1. So we start with 0 and we go 1. Okay. And then we've run out of numbers already because it's only 2 numbers. So we start again. So we go 1, 0, 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0. So it carries on. And I got an email today that says there are only 10 people in the universe. There are only 10 different types of people in the universe. Those that understand binary and those that don't. Okay, because 10 is 2. Okay, so in binary, that is 2. So there's only 2 types of people. Okay, so hopefully you understand a little bit about binary. So binary has only got 2 numbers, and we count with those 2 numbers all the way. Why is this important? What could you possibly gain about this? The first thing is that everything that we do on computers and internet, everything works with zeros and ones. Absolutely everything works in zeros and ones. Okay. All information that we send, we don't send letters, we send zeros and ones on the internet. Things are either on or off. Why do we use binary to send information? It's simpler. Simpler is a good dish word. Simpler is not bad. Machine language, that's an average answer. I'll give you I'll tell you why we did it. It's for accuracy. Okay. If you think about Morse code is dots and dashes. There's no dots, medium dot, long dot, dash, long dash. Because you might get confused. Was that a dot or a dash or like a... So if you've only got dots and dashes, you know it was either a dot or a dash. Same thing with binary. Either it's on or it's off. There's no discrepancy between the two. And if things get slightly distorted along the way, you should be able to tell whether it was 0 or 1. So if you're talking on a microphone, for instance, and the sound kind of does that, and it's got to go through some type of filter, and it comes out again, it might look a little bit kind of like that. So it'll be a little bit distorted, but it'll be around about what it was originally. In computer terms, if you have around about what it was originally, your document's not going to look the same. So what we do is we only send zeros and ones. So we say that's 1, 0, 1, 0, 1, 0. And if it gets a little bit distorted, it might look a bit like that. But if you kind of have a line in the middle, you say, well, that was definitely a 1, that was definitely a 0, that was a 1, that was a 0, 1, 0. So you can, when information comes to you, you can tell that was a 0 or a 1. Even if it's got a little bit of noise in it, you say, well, that was a 0. And if it's got, if it sounds like a 1, it's most likely a 1. So you lose very little information. It's the most accurate way of sending information, using only 2 different options. There's a big problem with it, though. In the past, I could have said to you 4. Now I have to go 1, 0, 0. I have to send you 3 bits of information, whereas in the past I just sent you 1 bit of information. What it means is that we need to be faster. So everything on the internet needs to be fast. Okay. Switching equipment, when we talk about how expensive it is, it's because those things send zeros and ones through them so fast. Routers, why are they so expensive? What speed is my router? What speed switches and LAN and WAN do you have? It's all about those zeros and ones going through. Okay. So we've got to push zeros and ones through. So we take a Word document, break it down into zeros and ones, and we send those zeros and ones up and down the line. Okay, so everything's in zeros and ones. So we can send 0 or a 1 per second. So what that's saying is we can send 64,000 zeros and ones down a 64 kilobit per second line in 1 second. Okay, that means if there was a copier, or one of those lines that counts cars that go over it, if you look at how many cars can go over it, if the line's perfectly utilized, you'll count 64,000 zeros or ones in 1 second. Okay, they'll go past you. The first thing about this line is it's bidirectional. Bidirection, both directions. It means 64,000 can go in the one direction at the same time as 64,000 come in the other direction. So when we sell clients a 64K line, we could have sold them a 128K line and said, well, that's if we add both sides together. All right. Okay. But it's 64,000 bits in 1 second going in the other direction. Anyone know what speed those zeros and ones are traveling down that line? Speed of light. Correct. So everything on the internet also works at the speed of light. I had an argument the other day about if it's actually the speed of light or not. In a vacuum, it's the speed of light. Blah, blah, blah. It's there or thereabouts. It's basically the speed of light. Everything travels at the speed of light. Okay, so the zeros and ones are traveling at the speed of light. So if you think about it as a road again, because I like roads, it means that there's cars, 64,000 cars can travel down this road past a point in 1 second. And every car is traveling at the best speed possible. So hypothetically, every car is traveling at 120 k's an hour, 120 kilometers an hour. No can go faster, none can go slower. They can be back-to-back, means it's 64,000 a second. If there's some gaps in it, that means the line's not perfectly utilized. So you might not get as many through. But that road is able to handle 64,000 of them in a second. What happens if you need more cars to go down that road? What do? You increase the bandwidth. In other words, you put extra lanes in. Okay, put more lanes into that road. If you can't make the car go faster than 120 k's an hour, and in this instance we're talking about speed of light, so we can't make those zeros and ones go any faster. We need to have more lanes. More lanes is bandwidth. Okay, so when a client says to you, my line's too slow, you shouldn't say to him, you idiot, it's not. It's going at the speed of light. But in your head you should think, that line's not too slow, it's going at the speed of light. That's the fastest we can travel. That's the fastest zeros and ones can travel. Your line's not too slow, it's too narrow. Okay. So we need to give it more bandwidth. Okay, so that's what bandwidth is. Cool, is this all making sense? Is anyone bored yet? Everyone happy? Okay. Very nice of you. Tough audience. All right, so that's what speed, and that's what an internet line is. It's a 64K line. It's a 64 kilobit per second. All right. So if we carry on in the binary thing over here, we can see that. Anyone want to get that? No worries. So in binary, what happens is if you have a look at how many digits can represent numbers, one digit can represent up to 2 different numbers. It can represent a 0 and a 1. If we use 2 digits, we can represent up to 4 numbers, 0, 1, 2, and 3. If we use 3 digits, we can represent 8 numbers, okay, all the way to 7. And so it carries on. If we have 4 digits can represent up to 16 numbers. Okay? Does that make sense? 2 different numbers there, 4 different numbers there, 8 different numbers there, 16 different numbers there. The next one will probably be 32. The next one, 64, 128, 256, 512, 1024. Are those numbers familiar to you? Okay. speed of line. Always, if you go and sell a 64K line, why don't we just sell 50K lines and 100K lines? And it's all got to do with the zeros and ones. All got to do with binary. Okay, so that's why speeds are the way they are. Okay, that's why they're strange speeds. So everything ties back into this binary numbering system. When we get to 1024, a lot of the times we just say, well, that's about 1,000. Okay. So the other thing, there's just a little thing that you don't actually need to know. A kilo equals 1,000. A capital K actually equals 1,024. Okay. Don't know if you knew that. The next thing is, after you get a kilo line, you sometimes get a 1 meg line. What's a meg? A meg is 1,000 kilo. Okay, so meg equals 1,000 kilo. So it equals 1,000. The next one that you get is a gig. So when you get a gig, it's 1,000 meg. Okay, so these are different speeds. So it's just like a kilogram is 1,000 grams of something. A kilometer is 1,000 meters. So a meg is a million of them. Okay, it just goes up every time. When you're talking about this small k and the capital K, just by the way, you probably don't ever have to know this, but that's how you can distinguish between if it's 1,000 or 1,024. If you get to the meg and the gig, there's no way of differentiating. A small m is milli. That's much smaller than 1. Okay, it's 1,000th of 1 milligram. Okay, it's 1,000th of a gram. So you can't use big m's and little m's and big g's and little g's. Okay, you need to use big ones. So if you can't tell what it is, one of the ways of telling is if it's a B, generally it works in the thousands. If it's a capital B for bytes, generally it's 1,024. Just by the way. So if I say to you, I'm sending you a 2 megabyte file, a lot of people will say, well, that's 2,000 kilo, which is 2 million bytes of information. And because it's a byte, you could say that it's 16 million bits, or zeros and ones. 16 million bits. Okay. The reality of that is that because there's a B there, generally it's actually 16 times 1024 times 1024. All of this is just for your own interest, in case you. The reason, the places you might see this is you get an email or you see a file and you look at your hard disk size and they say, I've given you a 60 gig hard drive, and you look and it says 60 gigs. And then you look at different properties of the hard drive and you see it says 62,000 megabytes. You go, oh, whatever, I got more than 60 gigs. Okay, you didn't, because that bytes is actually supposed to be times 1024. Okay, when you sell a client a 1 meg line, it's actually a 1024K line. Okay, it's not a 1,000. So they're getting a little bit extra there. We've already given them a bit more. Okay. All right. So that's why the file sizes look different and hard drive sizes look different. And sometimes you get an email that's this big, and then when you save it and you save the file, it's a different size. You go, well, that's a bit strange. You try to put files into a CD and it looks like it won't fit, and suddenly it does fit. Like the CD is 740 meg or whatever it is, and the file you've got is 741,000 kilo. And you think, well, it's not going to fit, and then it does. Okay. That's the reason. Okay, because there's 1024 little discrepancy comes in there. What you should start understanding, though, is a 64 kilobit per second line tells you how many zeros and ones you can get down that line. So now you can say, well, how long will a 2 meg file take me to send? Someone says, oh, the file was 2 megs, took forever. So you can say, all right, 2 meg file, how many zeros and ones is it? It's that many zeros and ones. And I can send 16,000 of them in a second. So how many seconds will it take? So how many minutes will it take? So when you log on from home, you look at that file, you can actually sit there. By the time you've worked it out, it'll probably be there. Okay. So you can actually work out how fast these things are, how big files are, and it starts to make a little bit more sense in terms of a document, an image. It's a 20 kilo image, and you go, well, I don't know. What does 20 kilo actually mean? It talks about how many zeros and ones are needed to carry that information to reproduce that image in some software. Okay. Is this helpful? If anyone's bored, you can go. Except Brett. He's just here for fun. All right, so that's zeros and ones. Does that explain why we use zeros and ones and why we use binary, etc.? So IS, we've got these connections over here, and we connect internationally via satellite and fiber. What's faster, satellite or fiber? Fiber. Let's have a vote. Who says fiber? Faster. 1, 2, 3, 4, 5, 6. Who says satellite? 1. Okay, we've got 6 on 1 for satellite versus fiber. The one thing I told you is speed of light. None of them are faster. They both travel at the speed of light, excluding the little bit of slowing down in a vacuum argument which I had and the little bouncing in the piece of fiber which I had. They both travel at the speed of light. So why do we think fiber's faster? The reason we think it's faster is because the world looks like that, roughly. There's SA, there's the UK. We've got this fiber connection going to the UK, there or thereabouts. And we've got the satellite connection, which does that. Okay. Both of them travel at the speed of light. The one's a longer journey. Okay. So if you drive to Durban, it takes you 5 hours, and then you drive to Durban via Cape Town, and it takes you 15, 20, 24 hours. It's because it's a longer journey, but you still drove at 120 k's an hour. Okay, just a longer journey. Both are the same speed. The difference between these two is latency. It's the journey time. So if you go to the UK and back, it'll take you around about 200 milliseconds. That's a small s. Milli means a thousandth of. So it's 0.2 seconds. It'll take you about just under about 20% of a second to get there and back, okay, at the speed of light. And that's called the latency. Okay, the latency, how much extra time it takes to get there and back. On satellite, latency is, what is it, 600, huh? 600 milliseconds. So 600 milliseconds on satellite. So satellite takes a little longer to get there, but they're both traveling at the speed of light. Cool. Easy to understand. All right. So we're sending zeros and ones up and down these lines, and let's start thinking about what these zeros and ones are all about. The first thing is we talk about satellite and fiber, and we're saying that they both travel at the speed of light. Okay. So in terms of a road, it means that we've got roads that travel at and cars are traveling at the speed of light, or 120 kilometers an hour, etc., etc. They're traveling at a certain speed. The one is satellite and the one's fiber. So what's the difference between those in IT terms and in analogy terms? It just means that the one's built out of concrete and the one's built out of tar. The one might be a sand road and you just have to hold on tight to the steering wheel at 120 k's an hour. So you get different mediums. And your dial-up line at home is a piece of copper, comes through copper. Those zeros and ones that come from your computer are traveling at the speed of light. Okay. So your modem at home, which you say is slower, is narrower. The bandwidth is less zeros and ones that can go through there. But when they go through, they're going through at the speed of light. Okay. So the first thing is the infrastructure that you run on. So we've got Ethernet cables that plug into the back of our computers. That's like copper. So stuff can run along copper. We've got satellite connections, which is radio waves going through the air. Speed of light. It's traveling along the speed of light. That's like a sand road. The fiber connections, it's like a concrete road. Okay, just in a tunnel if it's down underground. So these are all just piece of grass, sand, whatever that you're traveling cars on top of. What are some of the cars that you drive on those roads? Okay, so let me give you protocols. You must have heard of a whole bunch of protocols. You've probably heard of TCP/IP. Other than the DD, teamwork, commitment, professionalism, intellectual property. Have you heard of TCP/IP? Does anyone know what it means? Okay, transmission connection protocol / internet protocol, because I think transmission connection protocol or IP is within the TCP stack, which don't worry too much about. It's just this way of connecting. And what TCP/IP means in analogy terms, in road terms, for me, I think of vehicles. When I say vehicles, what I mean, I hope I've spelled it right. There's no little spell check on the board. The little red line squeals up. You can right mouse click and correct. So TCP/IP, and give me an example of a protocol. Give me an example of something in TCP/IP. HTTP. Okay, so you might have heard of HTTP. What does it stand for? Hypertext Transfer Protocol. Okay. Hypertext Transfer Protocol. And it's generally used for browsing. Okay, so when you want to look at a website, use HTTP to connect to it. Earlier on I was saying, if you've got a road and you can drive out of your road, you could drive to see your friends, you could drive to do whatever you wanted to. There's also, you could drive in a car, or you could drive on a bike, etc., etc. So different protocols are different things, different vehicles that will travel on sand, tar, concrete, etc. If you've got a boat, it's not going to travel on a road, and it's not a vehicle with wheels. So it's not in that kind of portfolio. In the past, when we were first an internet service provider, we had a lot of clients who had some different IBM protocol, and that was like a boat. It didn't travel on roads. So we talk about things like we'll encapsulate it in TCP/IP, which meant we'll take your boat, we'll put it on a trailer, and we'll get it to the other side, and we'll take it off the trailer. Okay, it was hectic. You sit there, and the client's talking about blah blah blah, and don't worry, we'll encapsulate in TCP/IP or decapsulate blah blah, and you just sit there thinking, what the hell's going on? All they were saying is, we've got a boat. So you need to say, if some guy talks about a protocol, you say, is that TCP/IP, which meant has it got wheels? And if he says no, it's not, we'll put it on a trailer. If he says yes, it does, then cool, it will drive on our roads. Okay, it was actually easy to understand, but it sounded a hell of a hectic. So for me, HTTP is a delivery van, and I'll tell you why. When you go, HTTP is generally for a website. So what you do, you make an HTTP request, which sounds complex, to a website for the home page or whatever it is. So what's actually happening is you're sending a delivery van to the shop and saying, I want all of that stuff. They put the stuff into the delivery van comes back to you, and it unpacks it onto your computer. Okay. So you've used this HTTP protocol. So why have a protocol? What is protocol all about? Let's think about something else. Let's think about SMTP, which is simple mail transfer protocol, which is what we use generally for email. Okay, so think about an email that you want to send somewhere, and think about if you had bought a pizza, okay, or you'd got some generic drugs from the generic pharmaceutical drugs from the pharmacy. The dude's coming around, he's going to bring it to you. Most likely he's going to be on a little motorbike, and he's going to have a little attachments section at the back. His attachments are his medicine. We think of them as attachments in a Word document. It'd be pretty inefficient for that guy to bring like a 20-foot truck to deliver your little bag of medicine. Okay, so a better way of doing that is to put it on a motorbike. Same thing, if you want a website, you say to the guy, go fetch that website for me. There's lots of furniture in that website. You can try to get the couch on the motorbike. It's just not going to work so well. It's possible, but it's not great. Okay, so we designed different protocols around different types of things that we want to transfer, different bits of information. So design the best way of sending that information. And that's what FTP, SMTP, it's just the best way to pack those zeros and ones so that they get to the other side in the best format. Okay. It also helps later on when you start saying, I want to talk to a web server, and everything's not just generic and you're letting everything in. So you can now look at it and say, okay, I expect it in a motorbike, so I'm building parking bays for motorbikes, so I'm building delivery areas. So it's better for later on when we start giving information back. Okay, so does that make sense what HTTP and FTP and all of that stuff is all about? So you get FTP, which you might have heard of. HTTPS is HTTP with security embedded. There's a whole bunch of other protocols. So SMTP for me is a motorbike. FTP, that's when you're like pushing a whole big file or bringing a whole big file. So I think of it as kind of a tanker, one of those tanker trucks bringing petrol. Pretty inefficient to bring petrol on the back of a motorbike. Okay, much better to bring in a big tanker. Okay, so we've designed different protocols to bring information across in the most efficient way. Okay, so that's a little bit about protocols and so on. Makes sense?
Yeah. You've made examples of each.
Yeah.
But an FTP, what would typically be an FTP? Would it be an application like SAP?
Okay. Generally, FTP is used for downloading information. So if, for instance, you want to download the latest Microsoft patches or so on, or the latest software from some website, you could make an FTP connection to that and download it. Another example is in our hosting environment. If you want to build a website, you build it on your computer. Now you've got all these files. You need to save them somewhere else. So you want to save them on a web server. So you make an FTP connection, say, here's my username, here's my password, and I'm pushing these files. The way you do that is you get FTP software. You actually get a piece of software that says, when I drag and drop there, put the username and password, I click it, and it sends it. And it sends those zeros and ones in the FTP protocol. FTP is a great protocol because it knows how to handle big files, and if it breaks, it knows where to pick up, and it can find the most efficient route and recompile all the zeros and ones on the other side, all the packets and bytes on the other side. Great protocol for sending big files. Wouldn't be as good if you sent an email in that way. So FTP would be used for something like that. And there's a whole bunch of different protocols. So the voice will work over a different protocol, as an example. Okay. Right. Next, so you want to connect to, you want to send someone an email and you want to browse, etc. But we don't really know how to get, we don't know how the network starts connecting. So let's talk about IP addresses. Okay. So what happens is, there's this IS or Internet Cloud, and should have been in our corporate blue. Here's a client's network, and I'll draw a network like that. And there's a user sitting over here on his PC. And the first thing that happens is when you want to talk to the internet, you need to have an IP address. We've all heard of IP addresses. Do you know how they go? Their numbers? So they go from 0 to 255. Dot 0 to 255, dot 0 to 255, dot 0 to 255. Okay. Does that make sense what I'm saying there? In other words, the first number, so an example would be 196. I think it's 8 bits will give you 256 numbers. So a byte. That's a byte and a byte and a byte and a byte. So 4 bytes will give you an IP address. Okay, that's why we started using those numbers. So everything on the internet, when you want to talk to someone, you can't kind of call them by their name. You need to call them by their IP address. So this little guy sitting over here, he gets an IP address, and it might be 196.36.19.4. Let's say that's the dude over there. Okay. Now, on the outside world, there's this website, and let's just call it ABC, or is that too boring? Sex.com. Right, let's just say abc.com. And that has got an IP address. Let's just call it 9. I'm not going to go through the whole IP address number. When that guy wants to look at a website, he needs to connect to abc.com. So what he actually does is he takes his browser, and he makes an HTTP connection with the website. So we talk about, make an HTTP connection, FTP, SMTP connection, handshake. We'll do a handshake. All it means is I'm sending this thing off, and I'm saying, here's a delivery van. It's from this IP address 4. I'm sending it to 9. Can you pack your website in it? Once it's packed the website in it, it comes back. Okay, that's a whole handshake. But how did I know that number was 9? I need something to tell me, because I can't remember the IP address of everything that I want to go to. So along the way, we've got, no worries, something called DNS. Okay. What does DNS stand for? Domain Name Service. Okay. There's two primary things in DNS server. I think there's about 4 different things, but anyway. There's 2 main things that you need. The first is an A reference, or your A record. And your A reference tells you about websites. So it says to you, if there's a www.abc.co.za or .com, whatever, that equals 9. In other words, it equals 196.17.3.9. Okay? Gives you an IP address. So what actually happens is this guy says, I want to go to www.abc.com or .co.za. He ends up going to a DNS server. The DNS server says, that's 9 you need to go to. So he says, okay, I'm going to 9. So he goes, finds routers, direct him. So the router's like a cop. It's saying, you come this way, you go that way. He's looking after the traffic, making sure there's not too many cars, prioritizing sometimes the cars, all the red cars first, all the blue cars next, and he'll take all that traffic and send it up the right route. So he gets the DNS server and he finds out that it's 9. So now he makes an HTTP connection with 9. 9 knows that he's 4 and starts sending information back to 4. Okay, makes sense. So you're making your handshake using DNS servers. Same thing happens with email. There's another thing in your DNS server called an MX record. You might have heard of these. You should have. An MX record says that anything at abc.co.za equals 7 or whatever the number is. So somewhere over here, the guy's got a mail server. And that IP address for that mail server is 7. Okay. So what happens is you send an email out, send it to joe@abc.com. Your mail makes a DNS query, says, where's abc.com? It says, yeah, that's 7. Quickly go to 7. So he goes to 7, does a handshake, says, hi, I want to send a mail to joe@abc.com. Mail server on the other side either says, yeah, send it, or it says, I don't have a Joe, whatever it is. And then they start that SMTP handshake and connection, and it starts sending in that information. Okay. In reality, what generally happens is this guy's sitting over here, and there's a mail server on his network too. Mail server. So he connects to that mail server across this LAN. He actually gives it to that mail server, and the mail server goes and delivers it to this mail server, and the little user on the other side comes and fetches his mail from that mail server. Okay. So when we get email here, it doesn't come directly to our inboxes. It goes to the IS exchange environment, and then we make a little connection, get our mail. We're not doing any of the sending on our own computers. The main exchange servers are doing the sending and receiving. Okay, so we get those servers to do it. A server, what does a server look like? Do you know what a mail server looks like? And a web server. Do you know what those two look like? Anyone know? Anyone know? They look like that. A mail server and a web server and a firewall and anything can all look the same. All it is a computer running the right software. Okay? So when we give a client a web server or we give them a mail server, with the right software, they can all just be one thing. It's just a computer with the right software, mail server software. Okay. Firewall, in theory, can also be the same thing. You can put firewall software on there, and that becomes a firewall. Okay. So all these servers, don't worry about servers. It's a computer running the right thing. You can take a laptop, put the right software on there, put it into the hosting environment, and it will run, provided it's strong enough to handle all the load. Okay. But it's just a server, just a computer with the right software. Okay, so that's how we start doing handshakes, and that's how we use DNS to get us from the one place to the next. Okay, DNS exists in a few places. The first place DNS exists is on your own computer. On your own computer, you've actually got a little file called your host file, and sometimes you might have been asked to change your host file. All that's happening there is you telling your computer, when I type this in, this website in, go to this IP address. Don't ask anybody, just go there. Okay, so a lot of the time that'll be used if you type in intranet. It'll go to our intranet, and you think, wow, that was cool. Or you want to look at you want to look at something that's on your network, and it'll force you to look at that on your network. Okay, so your computer's got a little bit of DNS in it already. Okay, the next place that you'll generally have DNS is on your network. So everyone will run through a DNS server. Depending on the size of the client, some clients use our DNS server, some use their own. Again, if you type in intranet, the whole world can't see our intranet, and we don't go connect to some place called intranet or what's it called? Chill zone. There you go. If you type in chill zone, thanks, man. Get into trouble when marketing sees this. HR. So now I've been in trouble with both. So you type in chill zone, it goes to a specific place. The whole world doesn't know that chill zone is on our network. We put on our DNS servers as IS, as a company, not as a service provider. It forces us to go there. Okay. So that's the next place, and then IS has got its DNS servers, and then bigger service providers upstream have got DNS servers. And so a lot of the time we talk about it'll take 8 hours for your DNS to propagate. We tell clients that on the phone, like, we'll change your MX record. It's going to take 8 hours to propagate. What that means is that we put it on our server, but our server needs to tell the other server, hey, listen, there's been a changer, and that needs to filter back down to this DNS server there. There's a lot of filtering down. The guys correspond with each other every now and then, start copying information. I always use this, let me make a copy of that DNS entry. Okay, that's why it's filtering throughout. We can change on our server quickly, but not everyone will see that change immediately. Okay, so that's what DNS, etc. is based on and what it's for. Okay, makes sense. Okay, so next thing we'll talk about is caching. You might have heard about caching. There's lots of caching. IS does a lot of caching. So if we again look at the IS network, what happens is all of our clients are connecting to us, and we sell two different pieces of, when we're selling internet access as an example, we sometimes sell a client like a 128/64K. We always forget the abbreviation, but it's bits per second line. Sometimes sell them a line like that. What does that mean? It's talking about local and international bandwidth. In other words, we put 128 lanes into IS, no problem. It goes across, there's a peering point that you can use, there's other ISPs that you can get connected to. But if you try go on our international links, which cost us more money, we're only going to let you use 64 lanes at a time. Okay, so there's still 128 lanes from the office to us, and there's still 128 lanes to that peering point and all over. But if you try go overseas, there's only 64 that you can use. Okay. That's what that line means. So sometimes you don't add them together, and that's not the size of the line. If a client surfs everything 128K and then one guy tries to go internationally, he's not going to get 64 suddenly, because he's going to fight with the rest of the guys for that 128. That's the first bit. Once he's got to our network, he's got it, but he hasn't been able to get to our network fast enough. Okay, so that's why we break down into two different line sizes. Okay, local and international. And the reason we do that is because it's very expensive. Our international band is very, very expensive. Hence, we charge our clients for it. So if we can give them only a bit of what they need, we can deploy a little bit less, and we could all save money. Okay. Another cool thing that we do is caching. When people do go overseas, a lot of the time they're looking at the same information time and time again. So on our international bandwidth, just before people go out, we put a big cache server down. A cache server is a server that looks at the most commonly requested information, makes a copy of it, keeps it, and the next dude that asks for it just gives him a copy instead of going and fetching all the way from Microsoft again. It's the same. The last guy just asked me for that. I'm going to give it to you here. So we save huge, huge, huge bandwidth on our cache service in IS. Can't remember the stats exactly, but it's in the region of 100 megabits per second. Okay, somewhere around there. Okay. Caches are very clever in terms of their technology. So they might decide, some pages, web pages, might have a timeout for the cache, so it knows it can't keep it for longer than that. It might do a quick check to see that the file size hasn't changed or the date hasn't changed. It'll dynamically say, well, this has been too old, or I've had lots of requests for this, so let me go fetch it again. So different caches have different kind of thinking in it. But it's up to that cache server to decide how it actually works. Okay. So cache is all about storing this information so that you can resend that information. The first place any of us ever see cache is on our own computer. You know, when you're connected at home, dialing up, things are super fast. Click the back button, and that page comes up fast because the information is already on your computer. Okay, already on your computer, i.e. it was cached. It was cached on your computer. So your PC over here has got its own cache inside it. Okay, not on the screen, inside. Not on top, it's inside. So your computer's got its own cache in there, and that's where you clear your history and all of that. All those files are sitting in there. The next place that you might have a cache server is on the actual network as a client. You might have your own cache server there. The next place would be up at IS, where we send all of our clients through the cache. Okay, saves us huge bandwidth, obviously. It saves our clients too, because they save on what? How do they save? They save on latency. Okay, they get it from our service. Get it from here, you don't have to worry about the latency internationally. Okay. We don't currently, as far as I'm aware, put any cache servers locally. We don't cache any local information. In other words, there's nothing between peering points and other ISPs. We've got the largest hosting environment in the country, so no need to cache our own hosting stuff because it's going down our own network. It's right there, come swap across to there. Okay. So this network of ISs, in Rosebank as an example, we work on a gig network. People say, yeah, it's a gig network. And our hosting environment is running on a gig. So what is a gig? The rest abbreviation, gigabits per second. Okay? Gigabit per second. That means how many zeros and ones can go through there in 1 second. We've got a hosting environment next to that. And in that hosting environment, we run a gigabit per second network. And between the two, we've got a switch. And it's a gigabit per second switch. So what that means is that here's a highway that you can have 1,000 million cars on the highway, million cars, whatever it is, million cars on the highway, and 1,000 million, yeah, 1,000 million cars on the highway. There's another highway that has got 1,000 million lanes, or it's 1,000 million lanes. The other one's got 1,000 million lanes. In the middle of the two, we've got an intersection. But that intersection's got 1,000 million lanes. Okay. So what happens is you're driving along, go through the intersection, and you're on. It should make no difference. So you're driving along the N3, it's 3 lanes, goes branches off to Pretoria and branches off everywhere. You get onto the N1, it's 3 lanes, so you just drove straight on. Okay, it shouldn't slow you down. Okay. And it's right there, so there's no latency. So cache-wise, for this guy who comes up here, if he wants to look at something in the hosting, it takes the speed of light from there to get it until it starts coming back. Pretty fast. Okay, it's like 50 meters. Okay, so we don't have to cache it, essentially. All right. So yeah, that's a little bit about networks and speeds and switches. When you talk about the speed of a switch, and it's a gigabit switch or it's a meg switch, that's how many zeros and ones it can transfer through that thing. Okay, it's different. In the hosting scenario, we talk about there's a server over there, and we charge them for the traffic that they send out. And an example is we give them 1,000 megs per month. Okay, so we say there you go, you can have 1,000 megabytes. What's the rest of the abbreviation there? Traffic? Anyone? Well, you're all technically correct because there is no rest of the abbreviation. It's 1,000 megabytes. That's it. So we talk about how many cars you can serve, not how fast we're serving those cars. So we tell them you're on a really fast network, you can serve this many cars, and then we'll start charging you after that. So it's like a toll gate with X number of cars you can go through. Okay, so when you talk about file sizes, it's not speed anymore. Okay, and generally when you talk about size of files and data and hard drives, we generally use bytes. When you're talking about speeds, we use bits. Okay, generally. Because a 64 kilobit per second line sounds more impressive than a 8 kilobyte per second line. Sounds faster. But a big file, you just wanted to reduce the complexity in it. All right, sounds like you're using less traffic. So generally with traffic and things like that and storage, bytes, speeds, bits as a norm. Obviously, you can just convert them. Okay, so that's a little bit about our network and how we send out and how our caching helps you. So it helps us saving bandwidth for all of these guys who make a connection to us. They get the information off this cache server, and the cache only gets it once. Okay, saves huge bandwidth for us. Makes sense? Okay. From an IP address point of view, you might have heard of dynamic and static IP addresses. You might have heard of that. So what happens is everything needs an IP address. So when you log on, one thing you could do is you could have a static IP address. In other words, IS gives you all these IP addresses. It says, here's your IP addresses, you can connect to the internet. So everyone gets an IP address, and boom, they connect, and everyone in the outside world knows who they are, and you communicate like that. The problem with that is, say for instance, you've been given an IP address, you forget what it is, or you get a new laptop, and you don't know what your IP address was, or people leave the organization, new people come, someone's not there for 2 months, that IP address is wasted. So static IP addresses are fine in some instances, but in some instances you want dynamic IP addresses. And what that means is as you log on, the network gives you an IP address. So you start talking to the outside world with this IP address that's allocated to you. That's the difference between dynamic and static IP addresses. Okay. You also get illegal IP addresses. Illegal IP addresses are a specific range of IP addresses that have been permanently reserved that mustn't be used on the internet. Okay? So what's the point of having them? It means that if you get a request from an illegal IP address, you can ignore it. If there's any outside routers in the outside world, just ignore them. What's the benefit of that? The benefit is that if you're an inside organization, you can use those illegal IP addresses without having to get an IP address. You can just start giving people IP addresses. So all computers can start talking to each other. They just can't talk to the outside world. Okay. So how do we get them to talk to the outside world? There's a couple of things we can do. We can use something called NATing. You might have heard of NAT. We'll NAT it for you. Don't worry, we'll use NAT to get you outside. Network Address Translation, NAT. So you'll have something over here which will do NATing for you. So what that does is this NAT over here has a whole bunch of IP addresses which the outside world does know, does recognize, does see, and IS has potentially given them to you. You've got all these ones inside. You don't care. Some are for printers, some are for people. But when someone tries to get outside, that little device will give you a new IP address for talking to the outside world. So change your communication for the outside world. Network address translates for you. Okay. There's something else that you get called proxying. So you might have heard of proxy. Proxy is a little different to NATing. Proxy, does anyone know what the word proxy means in normal English? Like non-IT. Proxy? Exactly. You give someone a role to do. So if you live in a townhouse complex and there's a AGM and you have to vote for someone, they sometimes give you a proxy form. If you're not going to be there, sign the proxy for someone else to vote on your behalf. So you're asking someone else to do something for you on your behalf. So you could get a proxy server on the network so that this user connects, says, go fetch www.abc.com. The proxy server says, I'll do that for you. Okay, it uses its IP address, it uses its thinking, it makes a connection to the outside world, goes and fetches that for you, brings it back and knows who you are and gives it to you. So it's done it on behalf of you. Okay. Proxying is different to NATing. NATing changes your IP address, lets it carry on. Proxying does it on behalf of you. Proxying is also different from caching. Caching says, I've got a copy of it, so I'll give it to you. If I don't have a copy of it, I'll go get it and then decide if I want to keep it or not. A lot of the time, proxying and caching work really well hand in hand. Because if you think about it, I'm going to go do it for you. I'm going to go fetch that website for you. Here you go. I'm going to deliver it. I'm going to go do it for the next guy. But if I'm doing it for the next guy, if I had just kept that, I could have given him that info if I already had it. So caching and proxying go hand in hand. Often you hear about a cache and proxy server. Those are two different technical things. Just quite cool that they go together. Okay, that makes sense. Cool. No questions on that. Easy peasy.
Can I ask?
Yeah, go wild.
Why is it that you cannot have more international bandwidth than local? Say 128/192.
Okay. We'd love to sell that, no problem. Think about this. You decide that you're going to, you need X amounts of international bandwidth. So you build a 128K line. In other words, you build a 4-lane highway and a 4-lane back. Out of your building to IS. So you've got 4 lanes. You drive to IS at 120 k's an hour. You hit IS. You go, right. How many lanes you got from you? So we've got 6 lanes for you. You go, you know, if all 4 of those ran all the way up, you'd have 2 lanes spare on the other side. Okay. Plus you can go locally if you want to. So if you had 6 lanes and only 4 of them were for international, no problem. If you sell someone a 128/192 line, lots of spare bandwidth for them to go internationally. Okay. Cool. What you also get is when we do sell those lines to clients, you get graphs of local international so they can see if the one's utilized. Because what might happen is your line's totally like free and it's not very utilized, but you can't browse them internationally. You might find that their international component's saturated. Graphs like that. Yeah. So your international is saturated, but your local's not saturated. There we go. Nice, nice. Makes no sense to me either. And I think they've got in and out, which are the wrong way around still, huh? Okay. So basically, if you look at a lot of clients' leased lines, because remember it's 4 lanes in both directions, most clients, their lanes coming to them are more utilized than the lanes going out because you're bringing information in. Okay. So there's a lot of places where the information can just be replicated and given to you rather than you having to push it out. Because you always think, well, in science, you know, for every action there's an equal opposite reaction. So how can someone be getting more than they're sending out? You go surf a couple of websites, you bring in information in, that website's kind of giving that information to you, but might not be on a client's network, might be on a service provider network. Okay. So most clients are bringing in more information than they're sending out. If they're sending out more information, you should go and talk to them about hosting, some bulk mailing service, or whatever the problem that they're sending so much information off their network. Okay. So most lines are utilized kind of more that way than they are that way. And that's the case with our, it's a terrible error, eh? And we find that with our international lines as well. If we're going internationally, much more downloaded that way than uploaded that way. A little bit better. Okay. What we have done though is all except for one, and that one might not be in existence anymore, of our international lines are bidirectional, okay, or symmetric, let me say, symmetric. So all lines that we've got are symmetric internationally. There might be one that's not symmetric. I know they're taking it out. But anyway, for all intents and purposes, our band is symmetric. So if we have 200 megabits per second, again, I've heard some service providers talk about 400 megabits per second. They add both sides going, both sides up. We talk about it in one direction. So we've got a lot of back bandwidth. Okay, so if we're hosting over here, good for clients overseas because they've got lots of bandwidth to pull that information back on. ADSL line is a different story. ADSL, what does it stand for? Asynchronous, asymmetric. exactly. Asymmetric is the key there. It's not symmetric. These 64K lines, 128K lines are symmetric. A dial-up line is generally symmetric, but it kind of has hiccups in the transfer there. The ADSL line is not symmetric, so you get 1,000 or 1024 kilobytes per second coming down, and you got a 256 going up, 256 kilobits per second going up. Okay, so it's not symmetric, but that's generally cool because generally we're pulling more information than we're sending. Okay, so it's quite a cool service from that point of view, but that's why it's ADSL. Okay, not SDSL or just DSL. Okay, so it's not symmetric. Okay. So yeah, that hopefully kind of puts into a little bit of techie stuff. Okay, around speeds.
What is the difference between set 1, set 2, set 3?
Set 2 and set 3, all of that is basically the roads the tunnels that we built under the ground. Okay, so that'll change every now and then. So the access guys will keep you up to speed. But set 2 is actually fiber. It's not satellite. Okay, it's just the name for it. It's surface. What is it? Sub-African terrestrial connection or whatever it is, I don't know. But it's an acronym, but it's actually fiber going under the sea. Okay, so that's just our road. We built a concrete road up to Portugal, wherever it breaks out in Portugal, and our satellite road is our actual physical satellite is this highway that we built out of concrete that goes up, or rope and goes up. Or, no, that's not set 3. That's a different connection. That's satellite connection. Okay, so there's different names for all of these connections, and the access guys will tell you they've got a map of it, the plan. You can see what our bandwidth is, what it's called, etc., etc. Okay. Okay, so that's how roughly it works. The last thing I think we're going to go through is I'll just draw for you a quick overview of some of the business units at IS and where they fit onto the network and how they came into existence. Okay, so dark. Wow. All right, so here's IS. Now we connect to this international internet again, and we connect up to peering point for the local internet. What actually happens across that peering point is we all service providers connecting to that peering point. But what we've done with 2 different people, Sykes and UUNet, is we said that whole model that I showed you right in the beginning, where you have a central point, everyone connects to the central point, that's the best thing, but we broke that model. And what we did was we connected directly with Sykes and directly with UUNet via separate connections. We broke that little thing. We still kept that piece in place, but we also connect directly up to them to increase the speeds of transfer, etc., between each other. The peering, you've heard about the peering problems, etc., that we've got. The peering problem is that that connection that we put directly with Sykes at the moment is not big enough. Okay, and I won't go into the kind of legalities around that, but there's arguments around increasing that and who should pay, etc., etc. Okay, but it's that problem is that old way of connecting where you've got a point, and this is IS, that's UUNet and Sykes. All of us connected and a whole bunch of other people connected too, and then what we did was we put direct lines into these guys because they're bigger. Didn't want to put so much road infrastructure in there where we could connect to these guys directly. Okay, so that's one of the issues we've got at the moment, but that's our peering point. In theory, we connect up to the local internet, excluding the IS client base via the peering point. In practice, there is a little bit of direct peering. Okay, direct peering agreements rather than peering point agreements. Okay, and that's having a bit of issue over there. We won't talk about that too much. Okay, so the first and foremost thing that we sell at IS is internet access. Okay, internet access, as I drew for you earlier, that's what a connection is normally a little lightning bolt. Okay, it's not like a direct line. What that connection looks like actually, it goes into telecom. So what we do is we've got a router on that side and a router on that side. Routers are drawn like that. We've also got these things called NTUs, little NTU, which is a network termination unit, which is telecom's way of taking that information that they've traversed along their lines and giving it to us in TCP/IP format. And because a piece of copper can handle so much information, remember we spoke about lanes and saying if you need more information, make the lane more lanes. What happens if you've got one lane and that lane is already too fast because everyone's traveling the speed of light? what you can do, you can't give someone half lane because the car won't go. You can say, that's your bit of time. That's your bit of time. You stop the car. So cars go and then they stop, and then they go and they stop. Kind of breaks in the traffic. Okay. So an NTU is actually takes little bits of time on that copper. It says, that's your time. That's your time. That's your time. So I can use the same piece of copper over and over again. All right. A little bit kind of complex-ish, but basically what happens after that is it goes through this telecom network, can go any route, and they've got a whole bunch of different routes, comes out on the other side. So we draw it as a data connection, but the reality of it is that it's a lot less straight line than that. Okay, goes through a whole network. Same thing for the IS network. If you send an email from here to someone in Cape Town, it doesn't necessarily go from Bryanston to Cape Town. In fact, it'll go from Bryanston to Rosebank. If the Cape Town line's down, it might go to Durban, and then from Durban to Cape Town. It'll follow the best route. Okay. Same thing in the telecom network. It looks a little more like that. Probably a good reflection of it. And then it comes out on the other side. Okay. So we just draw it to make it simple as a data connection, little lightning bolt. Okay.
What does the NTU stand for?
Network termination unit. Yeah. In the past, there used to be these little boxes that we used to have all over Rosebank in our network room. They were just boxes kind of everywhere connecting, or little time slots and little green lights flashing if it was a 64, it's flashing if it's a 128, flashing the speeds. Nowadays we get like a card, and in fact I haven't been there for years, so it might have even changed. Get a little card, and that can terminate 10 different clients' lines, and you get bigger cards and so on. So in the past they looked like that, and there's an actual physical piece of copper going to the one point, and then had these NTUs. Nowadays it's a lot slicker. You can have fiber going into a cabinet. It's got a whole bunch of things. Okay. Those Rosebanks are a really good place to go and have a look at some of these things. You can see NTUs, you'll see fiber connectivity from Telkom, because we talk about connecting directly internationally like it comes into our building. But the reality is it lands on some satellite stations, Telkom satellite stations, then they bring it through to like their offices in Rosebank. And from their offices in Rosebank to our office in Rosebank, we've got two separate fiber rings. The one goes down kind of under the ground and comes up into the bottom of the building. The one comes from the other side into the top of the server room. So we've got them coming in different places in the server room in Rosebank. So it's not like there's no satellites on our building. Similarly, there's no kind of piece of wire that comes in. We've got fiber ring, they call it. It's a different piece of fiber coming into the IS building. So that actually exists. Kind of, you can actually see it coming in. This satellite station is in, what's it called? Crowthorne, near the Crowthorne Shopping Centre. Just, you don't point. That's north. Okay, so a little bit, it's like 20 k's down the road, down Main Road. If you just follow down Main Road, you'll find Crowthorne, head of T Junction to the left. There's a whole bunch of satellites behind the spa and spur there. One of those was at one stage dedicated to us. So the satellite lands there, and then we bring it via Telkom's lines. It's a little more complex than just a kind of a line going in. Also in Bryanston, you'll see things like our cache servers, massive servers, 3 or 4 of them, big hard disk space, little displays in them saying how many megabits per second they're actually serving out, how much they're caching. I think it gives you kind of pages served out or megabits per second served out. And obviously for me, the nicest one is megabits, because you can actually tell how much info is being served out. It's nice to go and see those things. Okay, so even for us, when I draw that cloud, getting from here to Rosebank, it's a whole bunch of different routes via Telkom links, etc. So the first business that we've set up and got running is access. So it's internet access at its rawest. There's a lot of other features and stuff, and I don't want to offend the guys by saying it's internet access, but it's in its raw form, the fundamental of it is internet access. They've got things like that's rude. They've got things like their bandwidth management tools, so they can manage your bandwidth. You can say this much SMTP, this much FTP, this much for this division. These IP addresses got this percentage of my bandwidth. They've got a whole bunch of other services, not just internet access, but that's in its essence what we set it up for. Thanks. That's my internet access summary. We then got our VPN division. Now VPN, if you don't know what a VPN is, it stands for Virtual Private Network. Okay, what that means is IS has got all these branches. So we might have a Cape Town branch, Durban branch, PE branch. And what will happen is a client, if they've got a branch in Cape Town and a branch in Joburg, they could buy this long line from Telkom. Or what they could do is take their branch, connect it into IS in Cape Town, take their branch and connect it to us in Rosebank, and maybe in Durban, take your branch and connect it. Now, those 3 branches all have little lines just into IS. And then across the IS network, we let them talk to each other. Okay. So if our links between Cape Town and Joburg go down, there might be a redundant link to Durban. So their traffic will still go through. So they won't necessarily see it. So virtual private network, it's a private network. They think, but it's actually public. It's our network. So it looks like it's private. Now we've got 2 different virtual private networks. We've got an MPLS network and a switched network, but we hardly ever sell the switched. And to give you an idea, what does it actually mean? It means that if you built this massive highway and you wanted to say to people, don't worry, we'll make sure your cars are looked after. There's a couple of different ways you could do that. One, you could say, this lane is always reserved for you. Okay? That's one way. If this lane breaks, we'll route you this lane will become yours. We'll give you quality of service. If this lane breaks, you're the first most important person to use that other road, and we'll take that other guy off the road and put you on. So you get quality of service at platinum, gold, and silver. We'll put you on there first, second, third. We'll guarantee you this much downtime, latencies, etc. We'll guarantee you this little downtime. We shouldn't talk about this much downtime. Guarantee you no more than this much. So we can guarantee things based on the lanes. We could also color code the cars. We could say all the stuff that comes out from your network, we put a little blue sticker on. Then we know it's your car. No one else can look at your car. No one else can steal your car. On the other side, we know it's a blue car, so we give the blue sticker, all the blue stickered cars to you. Okay. We'll put a little gold sticker next to it so we know that it's your company and it's gold type service. So if a car comes to us and it's got a platinum sticker, we'll let him go before your gold sticker, but we still know that the red sticker is for his company, the blue sticker is for yours. Okay, so there's different ways of looking after your roads, and your vehicles on the roads. On the way to Joburg, you'll see some of the lanes have got those little cones in the road, so the bus can drive along during the day. So we talk about bursting. You can burst, which means that that's your lane, you can use it, but if no one's using the lane next to you and you need a little bit more, you can use both lanes. But if you're not using it, some other guy might burst into your lane. If both of you are there, we'll quickly stop the bursting and you'll both use your lanes. So that's what bursting is all about. It's not complex. You just take the other guy's lane for a little bit of time until he needs it, then you get off his lane. So a VPN is all about giving the guys like looking after their cars in a certain way prescribed by what they've paid for, making sure no one else gets their cars. Information only goes to them if it's their cars. All right. So that's what a VPN is all about. We connect you in multiple branches. It makes you look like you're connected like that between the branches. Okay, when you're actually connecting via the IS network. It's great because if one of these lines goes down, it's our problem. We look after the whole network. If that line went down for you, you don't have connections, you need to talk to Telkom, etc. Okay, so that's what a VPN is all about in its rawest form. So that's our VPN business. Okay, makes sense. Our hosting business, I spoke a little bit about it earlier, is this IS network, and right next to that is this hosting network. Okay, and it's connected obviously at very high speeds. It's a high-speed network. The IS is a high-speed network. Connect them together at high speed, so it looks like it's the IS network. So the first thing is we separated because I was talking about this fiber that comes in and these cache servers and DNS servers. We have like 3 or 4 DNS servers. We used to have them. I don't know what they're called now, but they used to be called Hermes and Apollo, and I think it's Herm was and Apollo isn't. I don't know about that. But you'll actually see Hermes was one of, if you do like a lookup of someone's domain, you might see that their domain is looked after by Hermes or Apollo, and then you know it's like an IIS, it's on our IIS DNS servers. So you've got lots of servers in this environment and lots of stuff happening in here. In a hosting environment, it's your computer. You want to come to it, you want to see it, you want to work on it, etc. Not a good place to put into that network room. So we built a separate network room, connected the two up. That's the only reason they're physically separated. Logically, there's very little separation from a logic point of view because it's big highways joined together. And the hosting was all about, originally, we used to build websites at IS. And one of the clients said to us, well, if you put it on my network, it's down my driveway. If my driveway falls, in other words, if there's big rainfall and no one can drive down my driveway, they can't see my website anymore. Can't you put it on your side? So we started putting websites on our side. And we built a hosting environment. It started with websites, but it's not about websites anymore. It's about applications in our environment. So it could be your mail service, could be web service, could be your ordering system, could be your online banking, applications in that environment. Okay, so that's where hosting really started from. whole bunch of servers in that environment. They've got back, and they've got much more than just putting your server in our environment. They talk about obviously the right environment, the right speeds, doing backups, doing firewalling, etc., etc. Okay. The next area we'll talk about is Brett's area, security. Security is all about this information that these zeros and ones that are traveling down. What are these zeros and ones doing, and how can we make sure that they're not doing destructive things to a client's network? It's all about trying to stop intentional attacks on a client's network, or intentional theft, or any of that type of thing, misuse of networks. So we put in place security devices that will actually look after. In your hosting environment, you might have a server there. You might put some firewalls in front of that server. Firewalls normally represented by a little triangle. On your network, if that's your network, you put a little firewall in front of your network. So what a firewall is, it's a security guard in its rawest form. It's a security guard, and I always think of him as a security guard, and he's got a set of rules. He says, if a guy comes in with a delivery van, ask him where he's going to, and if he's going to the Europa shop or the canteen, delivery van's cool. If he says he's going to kind of see someone in a building, you go, why are you in a delivery van? Okay, so don't let him in. If a guy comes on his motorbike and he says he's going to see the diesel section, you go, well, you can't go there, you know. If he comes in a big truck and he says, I'm delivering diesel, so that's fine, diesel, and he's going to the diesel place, that's fine. So it looks at the protocol, where you're coming from. He might say, we only let diesel in if it's got a Caltex sticker on or a Shell sticker. Now I'll offend some clients. So look at where that's coming from, where it's going to, and what it's doing as a security guard. So in firewalling terms, you say, request comes through, little SMTP handshake that's trying to happen. He goes, I'm trying to do SMTP to this IP address, and I'm from this IP address. Firewall looks, says that's cool or that's not cool. If, for instance, I'm trying to do an SMTP handshake to a web server, which is not a mail server, I'm going to can it. At the same time, I'm going to write it down, so I keep a log of all of this as well. That's what a firewall is, basically. If I try do an FTP connection to an FTP server on your network, but I'm from an IP address that I didn't expect, so from someone else, you go, I've only got a few guys who are FTPing to the server, so I'm not going to let you in. Okay, so security does, at its rawest, some firewalling, and that's what a firewall is in essence. It's a security guard. Then security also has a couple of other things, those caching and proxying that you can do. We can take care of some of those, and I'll talk to you about their products. It also does content management. So it looks at those zeros and ones that are coming down and says, yeah, I'm delivering diesel. So it has a look and says, oh, it smells like diesel, looks like diesel, you know, off it goes. So it can do some of that around security as well. Okay. So it looks after things that are going onto our client's network, things that are coming off of our client's network. Okay. There's a mobility division, and mobility is all about how you get onto our network in a mobile way. So the first thing is dial-up. You can get onto our network by dialing. IS has got those couple of branches, but we've also got POPs around the country. POPs are points of presence around the country. So you could dial up to a point of presence and get internet access from that point of presence. The whole methodology and how that goes, I don't think we've got time for now. It's kind of the right routers and how you get assigned an IP address and where you get authenticated from. Some other time, or the dial guys, the mobility guys can take you through that. But there's two general flavors from a dial-up point of view. The one is you might be wanting to dial up to your company network. So when we're at home and we want to work at home, you dial up and then you're on the network. It's as if you're on the network. There's some security magic and you're on the network. Okay. Clients who want to do that, they don't necessarily want to have dial-up modems at their offices so that you dial up. They rather say, okay, well, let the guy dial up to ICE and then bring him back down that leased line that I've got with you guys and let him think he's on the network that way. Okay, that's, what's it called now? Secure dial. Well, it used to be called VRAS, so I'm not sure what it's called now, but you get onto, it's a virtual RAS service. RAS is remote access service. So in the past, you dial up to your own network. Now you dial to ICE network and we'll push you down there. The other thing we've got is VISP, which is virtual ISP service. So we used to sell all these dial-up accounts to thousands and thousands of people. We used to have the brand Icon, which is a really strong brand in the market, but we stopped selling it directly. We started setting up points of presence and let other people resell our service. So we'll set you up as an ISP, call you an ISP, you're a virtual ISP. You tell people what your phone number is, but it's IS's phone number. You give them all your points of presence, it's our points of presence, and we let them connect to the internet via our connectivity, but we just charge you for it. Okay, you can charge all those little individual use virtual ISP service. And then Richard will take you through some of the other mobility things around how you get connected via wireless connectivity, etc., etc. A whole bunch of different ways of getting connected. Getting your mobile phones connected for email. If you've got email on your network and you want to get it remotely. Okay? So that's mobility. The next one, I'm from application solutions, and we're all about taking a lot of what we've learned in the security space and the hosting space and taking what is everyone asking for from an application point of view. Let's put that application in our environment. Instead of them building it by themselves, buying servers and building it and deploying it, we'll do it in our environment, and then they just pay for however much they use it. So a good example is email. Instead of buying a mail server, put it on your network and looking after that mail, we'll put the mail in our environment, and you just pay for however many users you want on that mail server. Okay, so we take commonly used applications, put them into our environment, manage it for the client. They don't need to look after it, and we just charge them for however much they use it. Okay. We've got an Africa business unit. An Africa business unit says, if you want to start using these VPNs and connectivity, but you've got branches throughout Africa, and they need to connect to you via a VPN or via internet access, we can connect them to the IS network. So we're basically building points of presence through Africa and getting people connected to the IS network through Africa. Okay? Fairly simple to understand. And then we've got voice. Voice division is all about saying we're allowed to talk on a phone, which is converted from phone to zeros and ones across the network. The zeros and ones go to the closest point, and they become voice again. Okay, that either happens through all the way digitally, doesn't leave a computer, it just stays on the network and computers, or it might go to the closest point and then break out into a telephone network and ring on someone's phone. Okay, so voice is all about making sure that we can use zeros and ones on our network to talk. Okay. And then we've got a couple of vertical industries which look at vertical areas of IS and say, let's get a couple of those solutions together, plus what the vertical is asking for. Let's build a new solution if we have to, and build that. And that's the business units at IS. That's what we all do. So we build and support these solutions. Clearly, sales sell them. Operations make sure that they're running all the time. And all the other divisions are there generally to support us as staff. Okay, HR, marketing, obviously internal, external, support sales as well. Legal, admin, billing our clients. Okay, that's in a nutshell what IS is all about. Cool. Happy. Anything you want to know? That makes sense. Easy stuff. Because the main lesson around this today is that you might hear things every day that don't make sense to you. Ask about them. You know what zeros and ones are all about. You know what bits and bytes are all about. You know a little bit about protocols, caching, DNS, FTP. You've heard a couple of things. And these things shouldn't be too complex after today. So what it means is you're going to hear about something else, which I haven't spoken about, and you're going to go, I don't know how that works. Either think about it going back to some of the fundamentals, or write it down and go and ask someone. And ask them for an English explanation. These things aren't hard. A lot of the time people just confuse you. I think they want to keep their jobs or something in IT. It's not hard stuff. Just find out, get an analogy for it, and work out how it actually works. It won't confuse you. So don't be scared. If you see stuff in proposals you don't understand, go and ask. If you get a client who says something you don't understand, don't make it up. Write it down and say, oh, I don't know what you mean. I'll find out what you mean. It's not hard stuff. Don't be scared of this technology. It's actually not hard stuff. Okay. Is anyone still feeling totally in the dark? Okay. All feeling good? Cool. Thanks. Thanks very much. Cool, man.